In this work, we propose neural HO fusion, a fast neural volumetric rendering under human-object interactions. 4D modeling of human-object interactions is critical for numerous applications. However, efficient volumetric capture and rendering of complex interaction scenarios, especially from sparse inputs, remain challenging. So we present a neural volumetric human object capture and rendering system using lightweight consumer RGBD sensors. In stark contrast with existing systems, our approach handles various complex human-object interaction scenarios and even multi-person interactions. It achieves photorealistic layer-wise geometry and texture rendering in novel views for both the performers and interacted objects. This is the overview of our method. Given human-object interaction videos under sparse RGBD setting, we first utilize the instance segmentation approach to distinguish the human and object. To achieve high-quality human-object geometry for neural rendering under sparse RGBD cameras setting, neural HO fusion marries traditional non-rigid fusion with recent neural implicit modeling advances. Our scheme enables detailed and complete geometry generation under complex interactions and occlusions. For rendering, we introduce a layer-wise human-object texture rendering scheme, which combines volumetric and image-based rendering in both spatial and temporal domains. Finally, we can assemble the layer-wise result in the novel view to obtain photorealistic results. Next is the pipeline. For human reconstruction, we propose a fusion-based neural implicit scheme to reason about the human-only geometry details in novel views. Traditional fusion provides a global prior to support the network to infer a complete and temporal consistent human reconstructions in occlusion scenarios. Based on the human geometry proxy, we combine the image-based rendering with the traditional per-vertex texturing using albedo volume, through occlusion-aware blending weight learning. It enables accurate human appearance rendering in the target view with the level of texture detail in the spatially adjacent input. For object reconstruction, we adopt a template-aid robust object tracking pipeline with a specific initialization process. The initialization template is generated by an occupancy regression network. Then we extend the spatial neural blending into the temporal domain, which learns the blending weight from both the spatial and temporal candidate input views for photorealistic rendering. Here are more of our results. Our method achieves photorealistic layer-wise geometry and texture rendering in novel views for both the performers and interacted objects. We compared our method with fusion-based methods, unstructured fusion and robust fusion. Both methods cannot handle topological changes. We compared our method with implicit function-based method, neural human FVV. It cannot reconstruct correct geometry facing different object types and interactions, resulting in obvious artifacts in the texture. We further compared our method with function 4D. It hasn't taken human-object interactions into consideration, while our method adopts a layer-wise neural blending scheme to disentangle human and object for photorealistic performance rendering. We evaluated our neural human blending. Our full human blending scheme achieves both photorealistic and complete texture results. We evaluated our temporal neural object blending. We can faithfully recover the accurate texture even when some parts are severely occluded. Thanks for watching.